In this video, I will show you whether this faulty data about weight is normally distributed or not. First step, we need to sort this data from smallest to greatest. Highlight this faulty data. Go to Home. Go here. Sort smallest to largest. Then label, so I put the 1, 2. Then highlight this 1, 2. Where you see this plus, then drop down. We got this faulty data. Then next step, we need to figure out the mean of the weight. Put the equal sign. Then type average. Double click. Then you highlight this. Then put enter. You got the mean of the weight. So let's label. This is a mean. Then the standard deviation. First of all, we will figure out S sub n in this formula, which is the sample standard deviation. The standard deviation, put the equal sign, ST. You could say standard deviation P. Then you highlight this faulty data. Then enter. Let's work out unbiased estimate of population variance. This S sub n minus 1. S sub n minus 1 equals SQRT. Means square root, then parentheses, n is 40 divided by 39, n minus 1 is 39, then times this S sub n, then enter. We got 13.13 and so on. Basically, this Excel can work out this S sub n minus 1 directly. If you go to standard ST, standard deviation for samples, then you highlight this faulty data. You will get the same answer. But for your IA, try to show how you use S sub n to work out S sub n minus 1. You can use this Excel to check whether you get this correct S sub n minus 1. Next step, we will work out interval length. I try to divide all this data into 8 groups. You can change it into more than 8. It's really up to you. How to figure out the interval length? We put equal sign, parentheses, use the maximum value minus the minimum value, then divided by 8. Basically, I use this data to create 8 intervals, but we do have data less than minimum in the real world or greater than maximum. So basically, we are creating 10 intervals. The first upper bound will be the minimum value. lower will be 0 because this is the weight. You can put negative infinity if you want. For second interval, lower will be this upper. Then for upper bound will be this lower plus this interval length. Lower bound equals previous upper bound. Then upper bound equals the lower bound plus the interval length. Keep doing the same thing until you got the maximum value. Then this will be infinity. After you set up these intervals, you will count how many data in each interval. For each interval, we will use greater than or equal to lower bound, less than upper bound to count. So this will be 0. For second interval, its upper bound is 104.7925. Then I go to the data, find the value just less than this upper bound value. Then change its ordinal number into red. Then 111.68, 111.68, then 118.57, 118. After you complete this, let's count. We have 2 data for this interval. Then you can use this 4 minus 2. You will get 2 again. Then you use this 9 minus 4. You will get 5 data. 39 minus 29. You get 10. Next step, let's work out the probability of weight less than lower bound. You will get 0 here. Less than 97.90. Put the equal sign. Go to normal distribution. The value is a lower bound, comma, mean is this. The standard deviation, we will use this as sub n minus 1. Then click this true. Parentheses back, enter. You got this probability. Do exactly the same thing. Normal distribution. Lower bound, mean, standard deviation, then true, then enter. We will copy this, then put over here. This will be 1. Then we can figure out the probability of each interval using the probability of upper bound minus lower bound. Then enter. Using same way, I can figure out all of them. Then next step, I need to figure out expected frequency. Put equal sign. The probability of each interval times 40, because altogether 40 data. after you got this expected frequency, you need to check these important rules. So far, we learned two chi-square tests. Chi-square test of independence and chi-square GOF test. These rules will apply to both chi-square tests. The data in the expected frequency table must be greater than or equal to 5. Otherwise, the chi-square test is not valid. If the expected frequency table has values less than 5, get more data or recombine the data. For this expected frequency, we saw some values less than 5. So we have to combine the groups. Add the first 4 together. Put the equal sign. Then enter. You got this 9. It's greater than 5. This data is good. This data is good. This data is good. We need to combine these 3 together. So put equal sign. Add these 3. This will be modified expected frequency. For this observed frequency, we need to combine the groups. Also, put equal sign, put sum. I will add this 4 number together. Then this is 6. This is 9. 5. Stay. Then equal sign, put sum. Then we need to add this 3 number together. Count this observed frequency. You could say equals 40. Now let's create a table. For this table, in order to make the expected frequency greater than or equal to 5, we recombined the groups. When degree of freedom greater than 1, we will use this formula to work out chi-squared. Let's work out degree of freedom. We have 5 intervals. So 5 minus 1. Then minus, because we used unbiased estimation of population mean and standard deviation. So minus this 2. We got 2. Degree of freedom equals 2. So we got to use this formula. FO minus FE squared over FE. So we will put equal sign, parentheses. Observed frequency minus expected frequency squared. Then divided by this expected frequency. Then pull this down. We will get sum of these values. Sum. Then highlight this 5 data. Enter. we got chi-squared equals 1.85 as 3 sig figures. Let's compare this chi-squared value to the critical value. We got df is 2. Suppose the significance level is 5%. Then we got this critical value 5.991. HO is the data is normally distributed. H1, the data isn't normally distributed. Since we got this chi-squared equals 1.85, the critical value equals 5.991. Since chi-squared less than critical value, we don't reject HO, which means enough evidence to suggest that the data is normally distributed.